Welcome to all. In this session, we are going to learn about a pedal equation for a polar curves. In the previous sessions, we are discussing about the polar curves. In that polar curves, we have learned angle between radius vector and the tangent, how if two curves are intersect orthogonally, and the related problems we are going to learn. Today's class, we are going to learn the pedal equation of a polar curve. Okay. First, we have to understand what is pedal equation. If an equation involving the P and R, there is no angle present here now, an equation which involves P and R is called as a pedal equation. This is the main definition of a pedal equation. Here we are going to eliminate the angles. So one important theorem is there now. The length perpendicular from pole to tangent. That is the way I am going to prove now. Equation. That is an equation involves P and R called pedal equation. So we are going to derive a very important theorem, that is the length perpendicular from pole to tangent. So simply they ask in the examination, prove with usual notations like that. Prove with usual notation, 1 by PR square equal to 1 by R square into 1 plus 1 by R dr by d theta whole square. Or sometimes they ask 1 by R square equal to 1 plus 1 by R square dr by d theta whole square. So many form is there now. So general form I am writing here now. Okay. So we are going to proving this one. So as usual what we are learn in the previous classes, to find out the length angle between radius vector and the tangent, the same thing we will have to use the figure, but the continuation will be I am going to draw a perpendicular line from pole to tangent. Okay. So I have to see in the two-dimensional equation, this is the plane. I mark a one point. This is your polar curve. R equal to f of theta. This is your polar curve. Then after that, if mark a point P of R comma theta, it is a radius vector. Then I am going to join to the origin. This origin we call as an O. Okay. Then after that, we draw a tangent. This is theta. It is a phi and also phi. Its an angle is psi. So here they asked you the length perpendicular, finding the length perpendicular from pole to tangent. Just I am going to extend this tangent, call this as a point some m, and draw a perpendicular line from pole to this tangent. Now call this one as a small p. It is a notation. This is your radius vector small r. This is the figure we are going to write down here now. Then after that, you have to consider a right angle triangle. That is in P, M, O. So it's a make an angle of 90 degree. From right angle triangle, that is in P, M, O. It's a PMO or OMP, whatever you can call. OMP or PMP. It is a right angle triangle. So what is the sine theta we are getting from that? It is a sine phi. So I wanted to sine phi now. Sine phi equal to, it is an opposite by hypotenuse. The opposite angle is OM. Then you will divided by the hypotenuse will be coming here now. OP. The length of OM we simply call as a small p. Then after that, hypotenuse this one. if we make a cross multiplication of this, now we have P equal to R into sine phi. So one of the term will be getting now. Then after that, after getting these things from right angle triangle, I am getting a sine phi. Then we get P equal to R sine phi. So now I am going to prove this one. If you are going to proving of this one, now make a squaring on both sides. I am going to make a squaring on both sides. And simply, if you squaring on both sides, squaring both sides, what we get now here, P square, it should be equal to squaring on both sides, then become R square, then sine square phi. Now squaring of the term will be obtained. Then after that, I wanted to 1 by P. Just you take the reciprocal of this function. Taking reciprocal. What is the reciprocal of this? 1 by P square, 1 by R square, then 1 by sine square phi. We know that 1 by sine square we can simply write down as a cosecant square phi. So that one we can write down like that. 1 by P square equal to 1 by R square into cosecant square phi. So using your trigonometric relation, I am going to write down cosecant square in terms of cosine cot. That is 1 by P square equal to 1 by R square. It simply write down as 1 plus cot square phi. This is clear. First you squaring, then take the reciprocal, then 1 by sine square writing as a cosecant square. The cosecant square is 1 plus cot square. We know that the length perpendicular from pole to tangent, we know the formula. What is that formula? That is 1 by P square equal to 1 by R square into 1 plus, it is 1 by R dr by d theta whole square. Your cot phi is the length perpendicular from pole to tangent. Sorry, not length perpendicular from pole to tangent. It's an angle between radius vector and the tangent. So its cot square phi is 1 by R dr by d theta whole square. It's clear. Make a simplification of this. 1 by P square equal to 1 by R square into 1 plus the simplification of this 1 by R square into dr by d theta whole square. What they are asking here, the desired results are obtained. Sometimes some expansion form is there asked to you. So that's why I am going to expansion of this. Or 1 by P square equal to 1 by R square plus 1 by R power 4 dr by d theta whole square. So this is the results. We are getting a Padal equation, that is a length perpendicular from pole to tangent. Sometimes this equation reduces in different form also. Just you take a one note. What happens if I am taking u equal to 1 by r? If I am taking u equal to 1 by r. If we differentiate this one with respect to theta, then we have du by d theta. It is minus 1 by r square into du by d theta whole square. It's minus 1 by r square into differentiation of this one r is dr by d theta. Taking u equal to 1 by r. Then differentiation this one with respect to theta, that is du by d theta. The r differentiation is minus 1 by r square, then dr by d theta. If we make a squaring on both sides, we get du by d theta whole square. Negative become positive after making a squaring both sides. This becomes 1 by r power 4 dr by d theta whole square. Now I'm going to substitute this in this equation. If you call this as a star, now I'm going to substitute this in star. The star becomes 1 by p square should be equal to, if you call this one as u square plus, if you're taking u as an 1 by r, this become u square plus du by d theta we can also another form to write the Padal equation.
Working procedure to find Padal equation, that is PR equation. We call simply PR equation.
The first procedure, we have to take a given polar curve r equal to f of theta for a polar curve. For a polar curve r equal to f of theta, we should eliminate the value of phi. So that means we have to find out the value of pi. After finding out the value of pi, you should have to put in this equation p equal to r into sin phi. What the given curve, polar curve, you should have to take this polar curve and simplified it by using the concept of length what is that angle between radius vector and the tangent. Using that, you have to extract the value of phi. After obtaining the value of phi, you have to substitute in this equation p equal to r sin phi. If phi are getting very easily, they can use this formula. Sometimes if it doesn't get the value of phi directly, in that case, you have to use this formula for Padal equation. 1 by p square equal to 1 by r square, then 1 plus 1 by r square into dr by d theta whole square. Okay, if getting it directly, the phi value, you can use for finding the Padal equation, use this relation. Sometimes it doesn't get the value of phi directly. In that case, you can use this formula 1 by p square equal to 1 by r square, 1 plus 1 by r square into dr by d theta whole square. This is the main procedure. Okay, so this is the procedure we have to follow to solve or to find out the Padal equation, that is PR equation. The equation machine should contain only P and R is called as a Padal equation. The main thing is here we are going to eliminate the angle theta. Okay, so now I'm going to see some problems how to form a Padal equation. The form a Padal equation problems. Form Padal equation or simply PR equation. PR equation from the following curves. The first one I am taking this one. The first problem, first example, it's r times of a into 1 plus cos theta. So this is the first problem they given. So our duty is to find out the value of phi. If say is a Padal equation, the equation should contain P and R. So as usual in the last class problems, that means we are going to find out the angle between radius vector and the tangent. Same method we have to apply here now. So first taking log on both sides for this function. Taking log on both sides. If you are taking log on both sides, this become log r. Should be the product of two function is there. Now it is log a plus then logarithm of 1 plus cos theta. Okay. Now differentiate with respect to theta. This become 1 by r dr by d theta should be equal to, this become constant function 0. Then differentiation of this one is minus sin theta, then whole divided by 1 plus cos theta. Okay. Now we can write this as a cot phi because this is the angle between radius vector and the tangent, it is cot phi. Then I am going to extract the value of phi. I am going to reduce this function in terms of cot or maybe tan. So use the formula, the trigonometric ratio is an half angle sin theta by 2 into cos theta by 2, then whole divided by 2 times of cos square theta by, use the formula. Now these 2 and 2 will be cancelled, cosine and 1 cosine will be cancelled, and finally we have cot phi equal to, it is a minus times of sin theta by 2, then whole divided by cos theta by 2. So we know that cot phi should be equal to, it is a minus times of tan theta. Now I am going to convert the tan in terms of cot by using an allied angles. This is cot phi should be equal to, can I write this in this form, 90 plus theta by 2. It's the second quadrant. Sine is only the positive, the other functions are negative. Write on this cot of 90 plus theta by 2. Now cancellation of this, phi is 90 plus theta by 2. Now get the angle of phi, where directly we get the value of phi. For the pedal equation, once you are getting the value of phi, then use the pedal equation formula. We know that for pedal equation, P equal to R into sin phi. Okay. Then P should be equal to R into sin of the phi value you have to write down here, 90 plus theta by 2. Now we get P equal to R into, what is the value of this? Sin 90 plus theta by 2 is cos theta by 2. Using the allied angles, the second quadrant, sin positive, the function will be only the change, but sin cannot be changed. Then it becomes cos theta by 2. So in the beginning I told you, if you say it's a PR equation, it should be containing P and R. But in this equation some angle is there now. Cos theta by 2 is there. I am going to remove this cos theta by 2. Otherwise we cannot say it is a pedal equation. If you say pedal equation, its equation motion should containing only P and R. Okay. Now P equal to, if you go to elimination of this one, of cos theta by 2, use your given equation. What is the given equation here? So just I am writing here, from given equation R equal to A times of 1 plus cos theta. Using this relation, you get the value of cos theta by 2. Okay. R by A should be equal to 1 plus cos theta. Is it clear? R by A should be equal to 1 plus cos theta. We can write down 2 cos square theta by 2. Or simply R by 2A is cos square theta by 2. Okay. So we know the value of cos square theta by 2, but we have a value of cos theta by 2. If we squaring both sides of this, what we get now? If we squaring both sides, we get P square equal to R square into cos square theta by 2. Now substitute the value of cos square theta by 2. What is that cos square theta by 2? It is an R square into R by 2A. If we make a cross multiplication, 2A into P square equal to R power 3. See here? In this equation there is no angle. This equation is containing only P and R along with constant. No problem about the constant. Simply say an equation is said to be a PR equation It should be containing only P and this is the required pedal equation. So this is the required pedal equation. Simply you can write. So this is the way, this is the procedure to find out the pedal.
R power m equal to A power m into cos m theta plus sin m theta.
R power m equal to A power m cos m theta plus sin m theta. Okay. Now as usual, solution, same, taking log on both sides, taking log on both sides. First we are taking the log on both sides. So now I am going to write it directly now. M into log R will be obtained, should be equal to m into log A plus, it's a logarithm of cos m theta plus sin m theta. This is the equation we obtained. Now differentiate with respect to theta. Now it comes in simplified form, then we directly go for differentiation with respect to theta. Now log R is 1 by R dr by d theta should be equal to, this is entirely a constant term, the differentiation of constant term with respect to theta, any variable, the function they become 0. Then differentiation of this first function differentiation plus, it is cos m theta plus sin m theta, then inside the function minus m sin m theta plus m cos m theta. Okay, now take down m as a common factor here. Now we get m into, so for this one we write down as a cot phi will be equal to, taking m as a common factor, we can also taking cos m theta as a common factor as well and good. If cos m theta, if you take a common factor, both numerator and denominator, this become 1 minus of instead of cos you can take in a sin now. Sin m theta, this become, first I am writing this one. This is if you take a common factor, that is in cot m theta, then minus of 1, then whole divided by, again we can take a common factor of m sin m theta, this become 1, again if you take a common factor, only this one, sin m theta I have to take a common factor, that become cot m theta plus 1. Now cancellation of these two and these two, cot phi should be equal to, now use the formula in terms of cot, this is cot 45 degree plus m theta. Now cancellation of this, we get the value of phi is 45 plus m theta. Now you directly get the value of phi. So after getting this, now I have to apply this phi in the pedal equation. We know that pedal equation for polar curve. P equal to R times of sin phi. Okay. Now use this one. P equal to R into sin phi value, it is 45 plus m theta. Now for the pedal equation for the polar curve, we are use P equal to R sin phi, because why I am taking this formula, we get the phi value directly. that is n phi equal to 45 plus m theta. Now substitution for that, we get P equal to R into sin 45 plus m theta. So if we say Pedahl equation, what the main procedure is, we are going to eliminate the value of m theta. Now expand this using a sin A plus B formula. Now use sin A plus B formula. What is that? Sin A cos B plus cos A sin B. Use this formula. Your A value is 45 and B value is m theta. Sin 45 into cos m theta plus cos 45 into sin m theta. Okay. We know the value of cos 45 and sin 45. The value of cos 45 and sin 45 value is 1 by root 2 or into, this is cos m theta divided by 1 by root 2. In place of sin 45 you put 1 by root 2 plus 1 by root 2 into sin m theta. From these two take a common factor of 1 by root 2 outside. We have cos m theta plus sin m theta. Now we are going to elimination this very easily by using the substitution of a given problem. What is the given problem? See here. R power m equal to a power m cos m theta plus sin m theta. This is the substitution we have to use here now. In place of cos m theta plus sin m theta, we simply write down R power m divided by a power m. So here root 2 into P should be equal to, you have to use this one, R power m divided by a power m. We make a cross multiplication. This will give root 2 P a power m should be equal to R power m plus 1. So now see here, in this equation there is no angle theta is there now. So this is called a Pedahl equation. An equation which involves P and R called as a Pedahl equation. This is clear? Okay. So now I am going to take one more problem. In that problem we are going to use the another Pedahl equation, that is 1 by P square equal to 1 by R square into 1 plus 1 by R square into dr by d theta whole square. So that formula used, using that we can extract the Pedahl equation also. That type of problem I am going to solve now. It is an R power n should be equal to a power n cos n theta plus b power n sin n theta. So as usual, using the same logarithmic equations, then apply here, then you have to extract the value of phi. Taking log on both sides. It is n into log R should be equal to n into, it is a logarithm of a power n cos n theta plus b power n sin n theta. Now differentiate this one. Differentiate with respect to theta. Now it becomes n into 1 by r dr by d theta. A power n cos n theta b power n sin n theta. It is minus n into a power n sin n theta plus n into b power n cos n theta. Now take down n as a common factor here now. So n into a cot phi value should be equal to minus a power n sin n theta plus b power n cos n theta, then whole divided by a power n cos n theta plus b power n sin n theta. Finally, you get the value of cot phi is minus a power n sin n theta plus b power n cos n theta, then whole divided by a power n cos n theta plus b power n sin n theta. See here, in this problem, we cannot extract the phi value directly. If you're doing it is highly impossible for doing a simplification of these to extract the value of phi to make this equation in terms of cot. Suppose if instead of bn you have an an, it's very easy for doing that. Here then different constant will be obtained. So that's why we cannot use p equal to r sin phi to extract the pedal equation. In that case, instead of that, we are using the other formula is there now. Now, for pedal equation, use this formula 1 by p square equal to 1 by r square, or maybe like that 1 plus 1 by r dr by d theta whole square. Your cot phi is simply we can also 1 by r dr by d theta. So simply you can write down 1 by p square equal to 1 by r square 1 plus cot square phi. So instead of this, you put this one. B power n cos n theta minus a power n sin n theta, then all divided by a power n cos n theta plus b power n sin n theta. We make a whole square of this. Now apply the power for these two functions, then take an LCM and make a simplification work. 1 by p square equal to 1 by r square into, now take an LCM by applying this, a power n cos n theta b power n sin n theta whole square plus b power n cos n theta minus a power n sin n theta whole square, then all divided by a power n cos n theta plus b power n sin n theta whole square. So here, apply this power to these two functions, then make an take an LCM, we get the equation in this form. Now we take a substitution for this one by using a given function. It is an a power n cos n theta, then b power n sin n theta. Use this relation. Instead of this, we are putting a r power n and expand this one by a plus b whole square, then a minus b whole square for make a simplification work. That is 1 by p square equal to 1 by r square. Now expand this one by using your a plus b whole square formula. And instead of this, we putting here this one r power n whole square. Okay. So now expand this one by using a plus b whole square. What we get now? A power 2n cos square n theta plus b power 2n sin square n theta plus 2 times of a power n b power n cos n theta into sin n theta. plus again the expansion of this one, b power 2n cos square n theta plus a power 2n sin square n theta minus 2 times of a power n b power n sin theta cos theta. See here, the positive and negative terms cancelled here. From these two, take a common factor of cos square n theta. The other two, you take a common factor of sin square n theta. Just you take a common factor of a power 2n and b power 2n from respective terms. We get like this. One by p square equal to 1 by r square. Now take a common factor from these two. What do we get now here? A power 2n, 1 is there now. One more a power 2n is there now here. If you take a common factor of a power 2n and a power 2n from these two, a power 2n we get cos square n theta plus sin square n theta. In the other equation, if you take a b power 2n, again we are getting a cos square n theta plus sin square n theta. Then all divided by then r power 2n. We know the result of this one. You put it 1. The identities of trigonometry, 1 by r square into a power 2n into 1 b power 2n into 1, then r power 2n. Then 1 by p square should be equal to a power 2n b power 2n divided by 2n plus 2. Or if you make a cross multiplication of this work, r power 2n plus 2 equal to p square into a power 2n then b power 2n. So this is the required solution for this particular polar curve.